Hello, very good evening. Today's class little bit late. There some technical issue was there, so we are sorry for that. Now we are going to start the class, and before going into the too much details of this today's class, I will tell you because my name is Harimohan Singh and I am a physics mentor. Okay, and working with the Sri Chaitanya Institute and one of the finest thing about this institute is that we are taking care of the students and very deeply, and we take all the things, all considerations, all the problems of the students, maybe academic related or maybe a non-academic related also. We are trying to resolve them on the time. Okay, now come to the points when we are discussing the physics, and in last few classes we have taken today's 13th class, and before that the 12 classes I have taken, and that is related to the one topic, that one chapter actually, electric charges and electric field, the first chapter of the class 12th NCERT. You can understand it. In that topic we have discussed what are the charges, what are the force acting between them and their properties, and forces, how they have to calculate between the point charges, that we have learned. After that we have discussed the what is the field, and related to the field we have discussed the different type of problems, what are the field lines and how they are related with each other. Okay, if it is a positive charges, negative charges, null points, all the things we have covered. Then we have went to the next topic, that was the one of the finest topic again, that is related to, we call it the conductors. So what are the conductors, what are their properties, what are the meaning of that, we have learned. Then we went to the next topic, that is the electric flux. So we have discussed what is the meaning of electric flux. Okay, and in this electric flux we have solved many problems, and now we are going to start one more thing related to this topic, that is the Gauss law. In Gauss's law there are two things is there, the calculation of electric field and calculation of flux. So calculation of flux we have covered in the last classes, and that was the last slide I'm putting it. Okay, this is approximately 88 slide or 89 slide, like that you can check it. And in this slide we are I was discussing one thing, is this how to calculate the flux related to the any charge. So that charges may be continuous, this may be discontinuous, means discrete charges. If they are discrete charges, then how to calculate it? If it is a continuous charges, how to calculate it? So for that we have solved some problems. Okay, that's the one thing. Now come to the point, what was the last problem I was discussing? That is the one of the finest thing. I skipped this derivation because not required for the NEET level, but we can understand this formula and how to use it. I'm just telling you. If there is a 1 point charge is there, that charge is q, and it is placed some distance x from a 1 on the axis of this ring or disk, we can say, but on the axis, remember this thing, not any general point. On the axis it is placed, okay, on the axis of this disk it is placed, okay, perpendicular to this disk, and we are seeing this distance is x, and the radius of the disk or ring, we are seeing that radius was r. So we can take this distance, it would be under root of x square plus r square. By using Pythagoras theorem we can tell it. It's a very basic thing. Now come to the point, second point, ki how to calculate this flux, or either we call it disk or ring. So we are putting it, the phi of disk is equal to q by 2 epsilon 1 minus cos theta. 1 minus cos theta, that is the one thing we are putting it. Okay, this derivation I have skipped, but it is an important part. Now we have to learn it in detail. Okay, so we are going into detail part, how to use it in differently. Okay, so I am telling you one question already been PYQ is there in JEE, so you can find it, what is the meaning of that. Please focus. So I am taking to you the next slide. Suppose this is the one, just wait. Suppose this is the one disk is there, beta, and again I am putting here charge, point charge. This charge is plus q charge is there, and this distance is x, and this is the radius is r. Okay, again I am saying ki what are the flux associated with it. So you can say directly is that this angle is equal to theta. So you have given the formula. So directly we can use the formula that flux is equal to q by 2 epsilon naught bracket 1 minus cos theta. 1 minus cos theta we can put it. Or we can say q by 2 epsilon naught bracket 1 minus, what is cos theta value? This would be x and this would be under root of x square plus r. This is the x upon under root of x square plus r square. We can put it, we can get the answer. This is the flux associated with this part. Okay, try to understand it. This is a very simple formula, we can use it. This is clear to everyone? Please reply beta. All the viewers, you can put your comments in the chat box. That would be good for us so that we can understand it. Okay, please reply. So this is a very basic part. So what was the question? I'm just telling you, this was the question given to you is if x is equal to also r. If x is also equal to r. If I'm putting x equal to r, directly you can put it, you will get the answer. What is the answer? You will say, so the flux is equal to q by 2 epsilon naught bracket 1 minus cos theta. If this x is also equal to r, that means this both are equal, and both are equal, that means this angle would be 45 degree, because r and r, this tan theta would be 1, that means angle is 45 degree. 45 degree means you can write cos 45 degree, you can put it. Cos 45 is 1 by root 2, so directly you can say, sir, phi is equal to q by 2 epsilon naught bracket 1 minus 1 by root 2. This is the value that we are going to understand this question. It is clear now, beta? Gayatri, very good, beta. It is clear to you? Now this answer is clear that we can solve it if it is x value given to you. Now another problem I'm just telling you, you have to understand it. Listen carefully. Listen carefully. Suppose this is the same disk is there, and I'm taking very simple case, very simple case on its axis. This is the axis is there. On its axis, if I'm putting here, beta, there are 2 point charges. This is q1 charge at distance of d1 from here, from the center. And this charge is, suppose I'm saying it, minus q2. Listen carefully. Minus q2, and this distance also from center is d2. And its radius is given to you r. There are 2 charges. This is the q1, this is the minus q2, this is the plus q1, you can say. It's the plus q1, and this is the minus q2. This separation is d1, this is d2. Now question is that what is the flux associated with this disk? The question, this is a very simple problem that I'm asking it, the flux associated with the disk. Okay, that I'm giving you the question that we can solve it. Okay, so I'm taking this question, how to solve this question. So what we have learned in the previous concept, same concept I'm applying here, and you will understand it. So how to apply the concept? Please focus on the board. If you see here, you will check. This is a q1 charge. q1 is a positive charge, beta. So due to q1, the field would be in this disk rightward direction. This direction. This is the rightward direction. This is the rightward direction. There is a flux due to 1, due to charge 1, because it is a positive charge. Okay, but similarly, if we see due to q2, also you will see the q2 is negative charge. Negative means it is also radially inward charge. That means its flux would be also rightward, not leftward. Try to understand it, because it's a negative charge. The flux would be also rightward direction. This is the direction, rightward direction. So this green direction I'm telling you for the phi 2. That means both flux are added. Both flux are added. So we can put the value and we can get the answer. So what you can say is that the total flux is equal to flux due to 1 plus flux due to 2. This is the total flux. So what is the flux due to 1? Flux due to 1 is q1 by 2 epsilon naught bracket 1 minus this formula. I will put it. You will say 1 minus d1 divided by under root of d1 square plus r square. It's the very basic. Similarly, due to Q2 also same direction, but now don't put again the minus sign because that we already considered here in the direction. So you will say plus Q2 by 2 epsilon. Don't put again minus, otherwise the answer would be wrong. Okay, 1 minus d2 divided by under root of d2 square plus r square beta. d2 square plus r square, that's the very simple answer that we can say 5. It's the final answer. It's the final answer. Can we solve? Is it clear to everyone, beta? Gayatri, another person also, you can tell it is clear or not clear, beta? Okay, I'm assuming it's clear to everyone now. Now we are moving to the next point, that the applications of Gauss law to calculate the different type of fields. So we are writing directly field. I'm just telling you, focus on that part. Okay, listen carefully. The very first thing is the flux field, electric field due to point charge. Point charge. There's a point charge is there. So using this Gauss law, we want to calculate it. So suppose there's a one a Gaussian surface we are drawing it, and this is the center. The plus q charge is present, and it is present at the center. And from here to here, this separation is a small r. I'm taking it. That means radius is small r, and it's the Gaussian surface beta. Gaussian surface. Gaussian surface means it's the closed surface. That means it's a spherical surface. Very good evening, beta. Gaussian surface. Okay, it's a Gaussian surface. This a Gaussian surface is there. Now we have to solve it. How to solve it? We already know the Gauss law. So what is Gauss law? Phi is equal to closed integral of E dot ds. E dot ds is equal to Q enclosed divided by epsilon. Q enclosed divided by epsilon. Now please focus. This is E and ds. ds is the area. Area vector we are taking it. So try to understand. Suppose I am taking here a small area, this portion, and this area I am taking as a ds. I am taking this area ds. The area vector would be outward. That I can say area vector is out. This is positive charge. Due to this positive charge, also the field is also outward. That is also E. The field is outward. So now you can check one thing. The area and field both are in same direction. Both are in same direction. That means their dot product would be E ds. So I can write directly the closed integral that become E ds because cos 0 is equal to 1. So you can say that is equal to Q enclosed means Q only by epsilon. Q enclosed, that we can write it. Now check this part. E, because from this center, the every point on this Gaussian surface at equal distance. Every point on this Gaussian surface is at equal distance. That means field is everywhere. Okay, field is everywhere. So field is everywhere same. That means this E value is constant everywhere on the Gaussian surface. So I can take this field is outside. So I can say closed integral of ds would be Q by epsilon. I can write like this. Q by epsilon. If you are putting this, you can understand one thing very clearly. You can say, sir, this is the E. Closed integral of ds means the complete area of this Gaussian surface. Closed integral of ds means complete area of this Gaussian surface. Because this is a spherical surface, that means that area would be 4 pi r square is equal to Q by epsilon. We can put it. Now 4 pi r square we already know. Put it. That means E is equal to from here. That is equal to Q by 4 pi epsilon into r square. This is the field that we already know. Q by 4 pi epsilon by r square. This is the electric field that we have to understand it. It is clear to everyone, beta? Okay. What you are saying, beta? What do you think with the cutoff? Cutoff, beta, very simple. It would be going to down. Okay. I cannot give you the exact number, but if I think little bit about it, I can say at least 70 to 80 marks. at least 70 to 80 marks, it will be go down for respective cutoff. Respective, maybe it will be little less or maybe little more also. That is, both is possible. So I'm taking a 70 to 80 marks. That would be okay. That would be the cutoff. Now this is a random number, beta. You are giving the 520 because it depends on the different places and different categories, different cutoff. Suppose Telangana cutoff would be different, and for different category also it would be different. Andhra Pradesh, it is totally different. Okay, if in north you are sitting in Delhi, it would be different. UP, it would be different. Bihar, it would be different. So different state, different category, it cutoff would be different. But first understand one thing: whatever your cutoff was last year, whatever your cutoff was last year, suppose, so what that cutoff, just try to remove 80 marks approximately. So if you are removing 80 marks, that means suppose your last year cutoff was 580. Suppose, so 580 was last year your cutoff. Now you can remove 80. That means this year chances maybe it will below also 500 would be cutoff. I am just giving you this my calculations. It can be 100% wrong. It can be 100% wrong. I am not betting on it. It would be correct. My calculations is approximately 80 marks would be plus minus, would be minus as compared to the last year. Okay, so this is the way. So this is the part that we are going to calculate due to point charge. So if point charge, very welcome beta Mugibara. Now try to understand it. So this is a point charge is there, and using this point charge we can find the field is. Okay, using Gauss law we have calculated. Now we are going for next problem. Suppose it is not a point charge. Okay, it is not a point charge, and suppose I am saying it is a spherical system, or a sphere is there, solid sphere is there, or spherical cell is there. So I am taking first spherical cell. Please understand. So I am calculating the next problem, that is equal to the electric field due to spherical cell. Spherical cell beta. So this is the one spherical cell is there. Its radius is r. And charge is on the surface. You can see the charge is on the surface. This is charge on the surface. Okay, this is charge on the surface. I suppose I am taking the charge is q. This is charge is q. Now question is that find the what beta? Field. Find the field. Maybe inside or maybe on the surface or outside, that we want to calculate it. So I am taking a very simple thing from here. At one point I am taking this is the P at inside point. Inside point I am taking. Or you can take another point. Suppose I am saying this is the A point, and you can take one point outside also here. Just outside you can put it. That is the B point. Or you can take another point. This is C point beta. Just means we can say outside this is spherical. So there can be three different points we can take it. One on the inside, one on the surface, and one is outside. So one by one we are going to calculate. Suppose I am calculating for first. Okay, first is the inside. Okay, inside the cell. Inside the cell. When I am writing inside the cell, just focus on that. What is inside the cell? This is the A case, the case 1. That means point A. So I am talking about point A. This is the point A. So for point A, again you will write the Gaussian surface, that means closed integral of E dot ds beta. Okay, is equal to Q enclosed divided by epsilon naught. Q enclosed divided by epsilon naught. We can put it. Now check here. What is the Q enclosed in this surface? Because at A, if you see the Gaussian surface, there is no inside charge, because charge is outer part for A, not at A. So inside A there is no charge. That means this charge enclosed is 0. If you put the charge is equal to 0, that means because ds is not 0, area of this Gaussian surface is not 0 at A. That means field has to be 0. So field inside the cell is equal to 0. That you have to understand. The field inside the cell is equal to 0. Now come to the second case. If I say on the surface, if I am putting on the surface, again you will say the phi is equal to closed integral of E dot ds. E dot ds is equal to Q enclosed divided by epsilon naught. It's the simple directly Gauss law we are writing. Using this Gauss law, if you see it here at B point, if you see the B point, here B point, what is happening? You are taking any here, one small area, this is ds. So area vector also outside and field also outside. Field also outside. Area vector also outside, field is also outside. That means both are parallel. Both are parallel means cos 0. And cos 0 is equal to how much? 1. So you can say in very next line, this become closed integral of E ds is equal to beta Q by epsilon naught. Q by epsilon naught. And field everywhere would be same because this is the r distance. You can take it that is from the center. So you can say this is equal to, we can say E into closed integral of ds is equal to Q by epsilon naught. Now second question comes to you. Okay sir, field is constant, we understood. What is the closed integral ds? Means if you take the B point, this surface, Gaussian surface, the B Gaussian surface, what is the area of this? This area would be approximately equal to the area of this spherical cell. What is the spherical cell area? 4 pi capital R square. You can say this is a 4 pi capital R square. E into 4 pi capital R square is equal to Q by epsilon naught, or E equal to Q by 4 pi epsilon naught into capital R square. This is the field. It is the field. Got it? Everyone please reply. This concept is clear up to here. If it is clear, then we can move to the next slide. Okay. Mugivara, Gayatri and other viewers also, you can reply. It is clear to everyone, beta? Very good, beta, Gayatri. Now it is clear. Now I am going for the outside point. If you are seeing for the outside point, what you will understand? Suppose I am taking this outside radius is equal to small r. What I am taking small r, it is the radius. So here also again you will do the same job. Okay, sir, I will take here one area and that area vector also outside and this field vector also outside. That means area vector and field vector both are parallel. Area vector and field vector again parallel. In the same calculation we will do in the next case also, case 3, outside point. I am taking here, you can write it. Third point, outside the cell. Outside the cell. If you write the outside the cell, what is the answer? You can say very simply that closed integral E dot ds, okay, is equal to Q enclosed divided by epsilon. That I am writing, that is equal to 5. So if you see the E and ds both are parallel, that means what is the dot product? That would be EDS only, because cos 0 is equal to 1. So you can say the closed integral EDS, okay, and that would be Q, because total charge is Q by epsilon. We can write it. Now I am writing E is also constant because everywhere the separation is same, distance is same from the center, from the charge. That means E equal to the closed integral ds is equal to Q by epsilon. We can write it. What is the closed integral of ds? That means the spherical cell, and that is equal to 4 pi small r. E equal into E into 4 pi small r square is equal to Q by epsilon naught. That means E equal to Q divided by 4 pi epsilon naught into r square. This is the answer. This is the answer. I think it is clear to everyone that we can calculate it. Yes or no, beta? Hi, beta Dinesh. Hello. Now, this we have done. Now we have to understand these all results. We can write it and we can understand it. So what I told you, the inside field, if you see here, the field inside the cell is equal to 0. On the surface is the q by 4 pi epsilon naught r square, and outside is a small r square. Q by 4 pi epsilon naught is small r square. We have to put it. Now come to the point. I am putting here. You will see that its graph I am going to draw it. This is the graph. E versus small r. E versus small r. If you check it here, this is the small r is equal to capital R. Small r is equal to capital R. In that case, what is happening here, beta? You can check very carefully. Up to here, the field is 0. Inside the shell field is 0. After that, what is happening, beta? This field is going to decrease. Field is going to decrease. How it is decreasing? 1 by r square. So field is decreasing here 1 by r square. You can see the field is decreasing 1 by r square. Okay, and this value equal to given to you, that the equal to beta q by, or small q you can write it, no problem, 4 pi epsilon naught by capital R square. It is on the surface that we are writing it. It's the maximum value. That means where the field is maximum. Okay, where the field is maximum? On the surface. So you have to understand it, field is maximum on the surface. As you are going outside or away from that surface, the field is going to decrease inversely. Inverse square law. Inverse square law, it is going to decrease it. But inside the cell, that is equal to 0. So inside the cell, field is equal to 0. Outside, it is decreasing 1 by r square. It is going to decrease this 1 by r square. It is clear to everyone, beta? Cartoon, Lover, Gayatri, Dinesh Rao, Mugiwara, and other person also, you can reply. It is clear to everyone, beta, that we have to understand it. This is we are talking about. Now, I can tell you one more thing that you have to be clear about it. What is that? Please focus, beta. We have seen this spherical cell, and the charge is on the spherical cell, beta, like this. Please understand my words, what I am telling you. Okay, this is charge, and this charge I am telling you q, and this radius is equal to, I am telling you, r. This radius is equal to r. Please focus. This radius is r and this charge is q. This is spherical cell. I am telling you spherical cell, beta. It is a spherical cell. Spherical cell. So in this spherical cell, we have to be clear about one more thing. What is that, beta? We can say, sir, we can write surface charge density. What we can write? Surface charge density. What is surface charge density? Sigma. That means charge divided by area. Charge divided by area. What is the area? Area of this spherical cell. What is surface area? That is equal to 4 pi capital R square. 4 pi capital R square. That we can write it sigma. Similarly, we can write, suppose sir, sigma is given. I want to write charge. So what is charge? Charge is equal to sigma into 4 pi R square. I can write it very, very simple. That is equal to q is equal to sigma into 4 pi R square. Now come to the point. Come to the point, and that we want to write it. Very simple. Field inside is 0. Very good. But field on the surface. I want to write field on the surface. If I want to write field on the surface, we have already seen in the previous slide. If you see here, what is the field on the surface? Inside is already 0. On the surface is q by 4 pi epsilon naught r square. Q by 4 pi epsilon naught r square. Use this data and write it here. That is equal to, sir, q divided by 4 pi epsilon naught into r square. That we can write it. Okay, and q value I already told you, sigma into 4 pi r square can be written. That means you can write it sigma into 4 pi r square. Okay, divide by 4 pi epsilon naught into r square. So from here 4 pi cancel, r square cancel. That means the E on the surface can also be written. That is sigma by epsilon naught. Important result, remember it. Important result is that you have to be clearly remember it. Okay. Similarly, now I want to write outside point also. This is the outside result we have seen. So for outside point, if I want to write it, you will check. I'm changing the color. You will understand. Suppose E outside I want to write. E outside is equal to Q divided by 4 pi epsilon naught into small r. So we can put it Q value, that is the sigma into 4 pi capital R square upon 4 pi epsilon naught into small r square. 4 pi cancelled. Then this becomes sigma capital R square upon epsilon naught into small r square. This is equal to E outside. So outside the spherical cell we can write this field, that will also be clear. It is clear to everyone, beta? Please reply. Please reply. It is clear to everyone, beta? It is clear or not clear? Gayatri, cartoon lover, Dinesh, Mukiwara, other persons also please reply. It is clear or not clear? Very good, beta Gayatri. Okay. Now we are moving to the solid sphere. If you see the solid sphere, you will understand it. Okay, but before moving to that, I will tell you one more thing. This on the surface part, it is the important part. Now you will say, sir, why important part? I will tell you. Because if it is a conducting solid sphere also, then also charge reside only on the surface. If it is conducting solid sphere also, then also charge reside only on the surface, not inside. That means it is equal to the spherical cell. So either I will call spherical cell or I can say conducting sphere. Conducting sphere. So what you understood from this part? You understood very simple thing. Ki conducting sphere is there. Then on the surface, what is the field? Sigma by epsilon. What is the inside field? 0. What is the away from the spherical cell? That is equal to sigma r square upon epsilon small r square. It's a very simple thing that we can put it. But remember one thing. Near to the surface, what is the field? Sigma by epsilon. Inside 0. That is clear. I already told you in the properties of conductor that field inside the conductor is equal to 0. Here also we have proved that field is 0. Okay, inside the conductor. Now come to the next point, that is the solid sphere, beta. Okay, non-conducting, uniformly charged solid sphere, beta. Solid sphere. We are talking about this. When I'm talking about this is the solid sphere there, so try to see the first picture. This is the picture, beta. So in this part, that the charge is uniformly distributed. Charge is uniformly distributed like this. Okay, this is uniformly distributed. In this case, okay, what we are putting it? Try to understand. This is the this is the radius, beta. You can check. This is the radius. That is the radius is r. Charge again I am taking q. No problem. So we have to understand it here. There are points we can take inside also, on the surface also, outside also. We have to solve it. That is our concern. Okay. So first I am solving here, first outside, then I am solving on the surface, then I am going for inside. So back calculation I am doing here one by one. Okay. So very first I am telling you, suppose outside point. So outside point you are taking it. So what you will do, suppose from the center, this separation from here to here, this is the point. This point is suppose A, and I am drawing it to the Gaussian surface. Sorry. Where the Gaussian surface? Yes, sorry. My mistake. This is the Gaussian surface, beta. It's the Gaussian surface is there, and its radius I am taking is small r. In this case, if you take the any surface here, this is a small portion, you are taking ds part. So you will say this is the ds vector, that means n vector, that is the radially outward. Field also radially outward, that means both are parallel. So I can apply that case and we will solve it. Okay, so I am solving for first outside the sphere. outside the sphere. This is the first case, outside the sphere. Outside the sphere, this case we are going to solve it. So what you will say, the closed integral E dot ds is equal to q enclosed divided by epsilon. Q enclosed divided by epsilon. In that case, what you are saying, beta, E and ds both are in same direction. That means if we do the dot product, that would be cos 0. Cos 0 is equal to 1. That means closed integral of E into ds is equal to q. What is total charge inside this? That is the q only. Total charge is q upon epsilon. Because in this Gaussian surface, total charge is q, means complete sphere is inside only. You can put it E again constant because from the center all distances are equal. So you can say the constant value. So E is outside the integration. You will say closed integral ds is equal to q by epsilon. Okay. Closed integral of ds is what, beta? This is the area of this Gaussian surface. Because this is a spherical cell, the area we already know, that is equal to 4 pi small r square. That is equal to q by epsilon. So what you get? The E equal to q by 4 pi epsilon into r square. That is the same result what we have got in the previous part. That means in a spherical cell case or solid sphere case, for outside the field is same. Field is same. Clear or not clear, beta? Now, the second case we are going to solve it. Suppose on the surface case, if you in the surface, if you take, you will say that small r become only capital R. Only small r is become capital R. You have to put it the same thing. So on the surface, second case, directly you can tell on the surface, beta, on the surface only small r become capital R. That means the field directly also you can write that is equal to q by 4 pi epsilon into capital R square. This is the field. Up to here, these two cases I have solved, case 1 and case 2, outside and on the surface, and both results are same as we have studied in the spherical cell also. Now please explain, please tell me in the chat box, it is clear to everyone, yes or no? It is clear or not clear, beta? Gayatri, Grisha, Mugivara, Cartoon Lover, and other questions also, whoever in the viewer list, they can reply. It is clear or not clear, beta? These two cases. If it is clear, then we can move to the third case, beta, inside part. Very good, beta. Gayatri. Now, the third case we are going to start it. Please focus on that case. Case 3. What is case number 3? That is given to you, very simple. Inside the sphere. Inside the sphere. When I am writing inside the sphere, what is the meaning of that? Please listen. You will say, sir, this is the sphere is there. This is the sphere. Now I am zooming it so that we can understand. Now this is a sphere. Okay, the same sphere, beta. This is a sphere. This is sphere. And its radius is equal to capital R. Its radius is equal to capital. And charge is of course Q, no doubt about it. Now, very first thing, we want to take a point inside the sphere, suppose here. And I want to just taking this Gaussian surface here only. Inside this point, suppose I am taking this point is A. Suppose I am taking this point is A. At this point, I want to calculate what is the field. This is our concern. Understood my concern? My concern is that this point is inside it. Now, very simple thing, we want to solve it. How to solve? Very basic. Now try to see. This question can be solved in two ways. Okay, many ways are there to solve it. I am taking a very simple case. Please understand it. I want to break this question into two parts. One part is this inside sphere, inside this dotted surface, that we can say is Gaussian surface inside sphere, and one is outside part, hollow part, that I want to write it. Due to both, I will get the result. I will add it. We will get the answer. That is a very simple method to calculate it. That means I want to break this question into like this. There are two part. One is this inside part, that radius is equal to small r, and the second part is this beta, this part. Second part is this. This is small r, this is capital R. That means here charges are present. This charge is present here, and this charge is present here. This is the case. This is the case. If we can solve this both, and we can get the answer. Very, very simple. So you can take this point is A, this point is A, that means here the point is A. That's the same question. Okay, now we have to calculate this A point field. Suppose due to this first case, this is E1 field, and due to the second case, this field is E2. If we know this E1 and E2, we have to add vectorly because they are a vector quantity, and we will get the net field. This is our way to solve this problem. Now you understood it? Now just check at E1 field. If you see this E1 field, it is very easy to solve. How to solve? Because for this small sphere, this is on the surface case. On the surface we already know. On the surface we already know the result. We can use it, we can get the answer. That means suppose this charge is Q1. If we get this charge Q1, then we can directly tell that the answer E1 would be Q1 by 4 pi epsilon small r square. That we have to calculate. Manoj. Okay. Hello beta. Focus on the question that you will understand. This is the E1 we want to calculate. So how to calculate E1? So for that we require Q1. So how to calculate Q1? That is only our concern. If we understand Q1, that means directly you can tell E1. Got it? Now how to calculate Q1? So you can use the volume charge density concept. What is volume charge concept? You will say the rho is equal to charge is Q in how much volume? 4 by 3 pi r Q. This is the volume. Directly you can use it. Okay. This is the density. Volume charge density means charge divided by volume. Okay. Now second is Q1 we want to calculate. What is Q1 beta? Q1 is equal to density into volume. Volume is how much? 4 by 3 pi r small q. Small r cube. We can put it. Now put the value. What is the rho? Rho is the q divided by 4 by 3 pi capital R Q multiplied by 4 by 3 pi small r cube. 4 by 3 pi is cancelled. This is a Q1. That means from here you can get Q1 is equal to, sir, capital Q small r q divided by capital R Q. This is the concern of this question. That means Q1 we know now. Q1 we know. Now please up to here, everyone please reply. This is clear to everyone or not, beta? Q1 is equal to Q is small r q divided by capital R Q. It is clear, beta? Manoj Kumar, why are you looking for the IDs? Okay, focus on the study. If you know the result, people will search your ID. If you are a good doctor, you are sitting in a AIMS Delhi or some good MBBS college, definitely the other person will look for your IDs. Okay, try to understand. Gayatri beta, this is clear. Now, using this concept, what we are going to solve it, the E1 I want to write it. So E1 formula we already know, Q divided by 4 pi r square. That means Q, I will put Q1, and in place of capital R square, I will use small r because this is the solid sphere, radius is small r. So I will use this result. I will write here beta Q E1 is equal to Q1 divided by 4 pi small r square. We can write. Now put the value of Q1. Q1 is equal to capital Q into R Q divided by capital R Q upon 4 pi epsilon into capital R, small r square. Just wait. Okay, I am putting it here. You can say 4 pi epsilon naught into small r. I can write like this. So just put what can be solved. This is the r square, this is r cube. If you cancel it, this is remaining small r. So this becomes q small r by 4 pi epsilon naught into capital R cube. This is your E1 result. It is the E1 result. It's a very simple thing. Got it? Now you know the E1. Now second question comes to you, what is the E2, sir? Because we require E2 also, then only we can answer it. Now come to this previous slide and you will see E2. For E2 calculation, if you check it, this is spherical cell, but this is a hollow. In hollow, I already told you, inside field is equal to 0. Inside field is equal to 0. Okay, the inside field is equal to 0 means at field at A is equal to 0, we have to understand. So field at A is equal to 0, you can put it. So what you will get? That means field E2 is equal to 0. So if I ask you what is the net field is equal to E1 plus E2 beta. You can write it vectorally, you can put it. That means E equal to E1, that means E2 is equal to 0. That means QR divided by 4 pi epsilon naught into capital R cube. This is the field inside. It is clear to everyone, beta? It is clear? It is clear or not clear, beta? Cartoon lover, Coulomb's law is definitely came first, okay, not after. And by the way, it's Newton's law of gravitation. But if you are talking about Einstein, Einstein also comment on gravitation in the general theory of relativity. In general theory of relativity, when he put some comments on gravity, if gravity can bend, if due to gravity the light can bend, he talked about it. So in that case, what is happening, beta? In that case, what is happening? This is in 20th century only. Okay, 1920 approximately. At that point of time, he talked about it. So it is a very recent case, not earlier. So definitely, what is happening? Coulomb's law was come first. Now this is the case. E equal to q r by 4 pi epsilon naught r cube. Very good result. We have to remember it. I'm collecting all the results one by one. We will understand it. So first, if I want to write it, listen carefully. Inside part. You will say E inside. E inside is equal to how much? That is equal to Q small r by 4 pi epsilon naught into capital R cube. That I can write it. Please understand. Second case is what, beta? E on the surface. On the surface. On the surface, beta. I am writing it on the surface. E on the surface, you will say the Q by 4 pi epsilon naught into capital R square. I can write it. Here the third case is the E outside. If you see the E outside, that I have written that the Q by 4 pi epsilon naught small r square. I can write it. This is the E. That I can write it. Now if you know this thing, now what we can write it? Now just draw the graph. E versus small r. E versus small r. If you see inside part, this field is directly proportional to small r. That means straight line passing through origin. So you can check it directly. You can say this is the E directly proportional to the straight line. That the small r is equal to capital R up to here, up to the surface. This is the straight line. That means E directly proportional to small r. After that, if you see here, it is inversely proportional to r square. That means it is going like this. Okay, here the E is inversely proportional to r square. This is the case. And maximum field again on the surface. Maximum field again on the surface, that value is equal to E value is equal to Q by 4 pi epsilon naught capital R square. This is the case that we are going to understand this topic. It is clear to everyone, beta? Gayatri, Swati, cartoon lover, Another question, please tell. This concept is clear to everyone? The graph is clear? The similar graph you see in the gravitation also. Okay. Now I am taking to the next point that is also very important. Okay. What is that value beta? Try to understand it. You already know the Q is equal to rho into 4 by 3 pi capital R cube. Volume charge density into volume. Okay, we can write it. Volume charge density into volume. So these results can also be converted into that form. So I'm going to convert like this here. You will say E inside is equal to, sir, how much? That would be rho into 4 by 3 pi capital R cube into small r divided by 4 pi epsilon naught into R cube. I can write. So what you will do, 4 pi cancel, R cube cancel. That means from here the E inside result is equal to beta, how much? Rho into small r divided by 3 epsilon naught. This is the result inside the sphere. Inside the sphere. Now come to the second result. What is the on the surface? So E on the surface, if you want to write it, what is the result? That you will say directly Q value. Q value already you know, rho into 4 by 3 pi capital R cube divided by 4 pi epsilon naught into R square. 4 pi again cancel, R square means this is cancelled. What you are getting from here, the E on the surface is equal to rho into capital R upon 3 epsilon. It is on the surface. Next thing, the third part is E outside. When I'm talking about E outside, you will understand it. The Q value again written as the rho into 4 by 3 pi capital R cube divided by 4 pi epsilon naught into small r square. Only 4 pi is cancelled. So what you are getting from here, that you can say E outside is equal to rho capital R cube divided by 3 epsilon naught into small r square. That is the result for the outside. Now please everyone just look for these results and tell me this is clear to everyone, yes or no. It is clear to everyone, yes or no, beta? Please reply. Swati, Gayatri, another person, please reply, beta. It is clear or not clear? Cartoon lover. Okay. So that we are understanding up to here, this is clear to everyone. Yes, Gayatri, beta. Now it is clear to everyone. Now we are going to move to the next point. What is that, beta? That is due to line charge. Vishnu Teja, good, beta. Now we are taking a linear charge is there, linear charge density is there. Now we want to solve the field due to that. Listen carefully. Suppose this is a one line charge is there, infinitely large, very large line charge is there. Okay, this is a long line charge, we call it, up to infinity, and its charge density is lambda. Linear charge density is lambda. I want to calculate the field due to this. How to calculate? Please focus. So suppose at a r distance I want to calculate. At a r distance, there is one point is there, suppose P point, and at this P point I want to calculate what is the field. So we are taking Gaussian surface because it's a linear charge. For symmetricity, if we want to take it, what is the better option? Better option is to take the cylinder. So I'm taking a one cylindrical Gaussian surface like this. If you are taking a Gaussian surface cylindrical, you will understand that this is cylindrical Gaussian surface. Okay, very basic. I am taking a Gaussian surface, that is the cylindrical Gaussian surface. Very good. Its radius is I am taking a cylinder, that is a small r, same distance. Okay, length you can take any value, that is not matter. This length is suppose L. You can take it, no problem. Now try to understand it. How many different surfaces I can consider here? You will say that there can be three surfaces. This is the surface 1. I am taking it, this lid, type of lid. This is the surface 2 that I can consider. This is also down lid. This is the up lid. This is down lid. This curved surface I can say this is surface 3. So there can be three different surfaces I can assume, and using these all three surfaces, this becomes closed surface now, and using this closed surface I can directly say one thing, that means now this is a closed surface, means this is a Gaussian surface, and we can calculate the what beta electric field. Okay, that's the very simple thing. Shivam Singh, actually beta I will talk to my technical team. They will reply for that. Okay, for JEE batch in online, how much fees they are putting it. Okay, but right now we are focusing on one thing, that is the medical. This is the medical classes. Actually, I am taking it. Okay, I am repeating again, beta Vishnu Teja. This is a one line charge. I want to calculate the field due to it. So for that, I am taking here Gaussian surface, and that Gaussian surface is nothing else cylindrical Gaussian surface. In this cylinder, there can be three faces I can assume it. How many faces? Three faces I can assume. Suppose this is a cylinder. By the way, it is not perfectly cylinder. This is one bottle. You can take one lid here, and the upper lid is there here. So there are two lids, one lid here, one lid here, and this is the curved surface. So we can assume it. This is the three surfaces are there. Now please focus. If you focus here, you will understand it. Sir, there's the Gauss law. If we write it, that the phi is equal to closed integral E dot ds is equal to q enclosed by epsilon naught. This is the way to write it. This is the way to write it. Correct? Now, but this is a closed integral. Closed integral means complete surface. Complete surface, but I told you this complete surface is made up of from surface 1, surface 2, surface 3. Okay, that means I can break this integration into three parts. That means I can say the integration for first surface E dot ds. Okay, then plus integration for second surface E dot ds. Then we can say the plus, just wait, I can remove this part. You can write that the for surface 3, that is also E dot ds. I can write like this. And that's the q enclosed. Q enclosed is how much? Because linear charge density is lambda. Total length is how much? L. So you can say lambda into L divided by epsilon naught. That's the very basic thing. This line is clear. This line is clear now. Okay, that we can put it, beta. Now using this concept, if you go for surface 1, surface 2, surface 3, you have to understand. Now I am taking it surface 1, surface 2, surface 3. Please focus on the board. If you take the surface 1, this is the surface. A small patch you can take. Here also you can take a small patch. Here also you can take a small patch. These are small patches. At surface 1, area vector would be like this, n cap. Okay. Here surface 2 also area vector would be like this. This is the n cap. Here at surface 3 would be also area vector would be like this, n cap. It is clear? Now put the field also. If you draw the field part, you will understand it more clearly. If you check the surface 1, the field is like this because it's radially outward due to this line charge. That's the field. Due to surface 3 also, that is all, surface 2 also, that is the field is radially outward like this. At surface 3 also, this is a radially outward field. These are field that I am drawing it. 1, 2, 3, this all surfaces we can draw like this. This is a very basic thing. Now please understand. So due to surface 1, if you see the due to surface 1, I am writing the integration of E dot ds. What is the angle between them? Check here. In surface 1, what is the angle between them? This is 90 degree. But cos 90 is equal to 0. That means first term becomes 0. Similarly for the surface 2 also. If you check the surface 2, beta. If you surface 2, again the electric field and this n cap, both are perpendicular. That means that is also become 0. Understanding? That the very basic thing. That means the second term also becomes 0. So first term 0, second term 0, the third term is remaining. We will solve. you will say 0 plus 0 plus third case. Third part, if you see the E and ds, both are parallel, directly you can say integration. You can put it, that is equal to E into ds beta, and that is equal to lambda L divided by epsilon naught. This is for surface 3 I am writing. E again constant because the distance are everywhere on this curved surface equal. That means you can take integration outside the integration, that is the ds is equal to for surface 3 into lambda into L by epsilon naught. This is cylinder. A cylinder's curved surface. If I ask you what is the area, the curved surface area, you can say that is equal to, sir, 2 pi small r into L, that is equal to lambda L by epsilon naught. From here L cancel, does not matter. E equal to what beta? Lambda by 2 pi epsilon naught into r. You can check carefully, very important result, that is equal to lambda by 2 pi epsilon naught r, that we can write. Here if you check it, this electric field is inversely proportional to r. That means if I want to draw the electric field versus r graph, that would be hyperbola. That would be hyperbola because field here is inversely proportional to small r. Got it? Yes sir, no sir beta? Now, cartoon lover, what you are putting? One question out of the topic, but an important doubt. Sir, in the school I read that the binding energy is the mass defect times 931 mega electron volt. Okay, you are saying something? Next. And mass defect, but you can multiply 931, okay, mega electron volt, by the way 931.5, it does not matter, you can take it, but take the mass defect in a unit, AMU, okay, not in kg beta, not kg or gram, don't take it, or milligram, take in unit, okay. AMU, you know that we call proton mass is 1 unit approximately, so that value we are writing, so you can take that, you will get answer. Next, also the binding energy is the mass defect into times c square, correct. Now here you will get that the joule value. If you are taking mass in the kg and multiply with the c square means 3 into 10 to the power 8 whole square, then you will get the binding energy in beta joule. Both answers same if you can calculate it, okay, and same thing. Got it? Okay beta, thank you. Now all of you, thank you for your patience and thank you beta. Bye bye, good evening, enjoy your time with a cup of tea, okay, and their next class is chemistry, you can enjoy it. Thank you, bye bye.